Hello and welcome back to the channel. Today we're going to be talking about Richard Feynman, a science innovator and educator, and someone who really pushed the boundaries of our understanding of physics. Before we get started, we'd just like to remind you that we would love it if you subscribe to the channel and like the videos that you enjoy. If we look at our analytics, we see that a lot of people come and watch only one or two times and then don't return. So it would be great if you guys would stick around and see what we have to offer. So let's talk a little bit about who Richard Feynman was. Richard Feynman was an American theoretical physicist, and he worked on several topics, including quantum mechanics, superfluidity, and particle physics. He was a Nobel Prize winner, taking the prize in 1965 jointly with Julian Schwinger and Shinichiro Tomonaga for their contributions to the development of quantum electrodynamics. Feynman was also the creator of the Feynman Diagram, which describes the behavior of subatomic particles and the mathematics behind them. Feynman became very popular and famous because of his lecture series and books, which helped make physics more popular for young people. Feynman also became more popular in the public eye due to his work on the Manhattan Projects and the Rogers Commission that investigated the Challenger disaster in the 70s. Let's talk a little bit about his scientific accomplishments. The first thing that he was really known for is path integral formulations of quantum mechanics. Path integral formalization is a description in quantum mechanics that generalizes the action principle of classical mechanics. Let's say that a little bit more easy. In classical mechanics, a system has only one single trajectory over time. Path integral formulation takes into account that in a quantum system, this can change and multiply in infinite ways. So instead of having just one way to get from A to B in classical physics, quantum mechanics has an infinite way. So here's 5 different of the infinite options it can take from A to B. Feynman completed the process of path integral formulation that had been started by Norbert Wiener and extended by Paul Dirac in 1933. So he kind of completed this work that others had started before him. He also did a lot to do with the theory of quantum electrodynamics. This is what he won his Nobel Prize for. Quantum electrodynamics is the field of electrodynamics in regards to relativism and quantum field theory. In essence, it describes how light and matter interact. This theory is the first where full agreement between quantum mechanics and special relativity was achieved, which was a big step towards a unifying theory of physics. QED, as it's abbreviated, mathematically describes all the phenomena involving electrically charged particles interacting by exchanging photons, and represents the quantum counterpart to classical electromagnetism. So this is another instance where Feynman took something that we understood in the classical sense and brought it into the quantum realm. Over here is one of his Feynman diagrams, which we'll talk a little bit more about in a minute. He also did a lot of work with superfluidity, and he did this with supercooled liquid helium. Superfluidity is the characteristic property of a fluid with zero viscosity, which therefore flows without the loss of energy, which is pretty cool. When stirred, a superfluid will form vortices that continue to rotate indefinitely. So they will just continue to go around and around like a little tornado or like a toilet flushing forever because there's no loss of energy. Helium-3 and helium-4 exhibit superfluidity when they are liquefied at a cryogenic temperature. Superfluidity is predicted, along with other special states of matter, by quantum physics, and this is something that Feynman managed to show the math for, and then actually experiment with. Feynman also worked with the Parton model of particle physics. In particle physics, the Parton model is a model of hadrons, such as protons and neutrons, and it was proposed by Feynman. It is a useful explanation for interpreting the cascades of radiation, which is called a Parton shower, produced from quantum chromodynamics, or the interactions of quarks mediated by gluons during a high-energy particle collision. A quark is a subatomic particle that's made up of hadrons, which, as we mentioned before, is like a proton and a neutron. Patron showers are simulated extensively to help physicists understand collider test results, and it was originally advanced by Feynman in 1969. So this is something that he came up with, and we now use a lot, especially with our collider tests that we do to discover smaller and smaller parts of the atom. Getting back to Feynman diagrams, they're really just a pictorial diagram that represents the mathematical expressions that describe the behavior of a subatomic particle interacting. These diagrams were introduced by Feynman in 1948 and have been used in several fields of physics since they were introduced. These diagrams have greatly aided other scientists in their own work, such as Frank Wilczek, and the calculations that he did that won him the 2004 Nobel Prize in Physics. And it also led to the observation of the Higgs particle. So these diagrams have become incredibly useful in the field of physics. In this diagram, an electron, which is this over here, and a positron here, hit each other and annihilate, because when these two things hit each other, they cancel each other out. That produces a photon, which is this blue line here. That becomes a quark-antiquark pair, the quark being Q, this thing up here, and the quark here, antiquark here. After which the antiquark radiates a gluon, represented by the green helix. So this basically summarizes a mathematical equation that explains how these particles interacted. The other things that Feynman were known well for are some projects and committees he worked on. The Manhattan Project, for one, was something that American scientists used to create the atomic bomb during the Second World War. Feynman worked on this project along with some other notable scientists at the time in the U.S. military. The product of this project were the first 3 atomic weapons, one of which was tested in the American Southwest, and the others were dropped in the Japanese cities Hiroshima and Nagasaki, killing hundreds of thousands. He also worked on the Rogers Commission, which investigated the Space Shuttle Challenger that broke apart in 1986 while exiting the planet. It was the first American space mission to have a fatality. The Rogers Commission was a presidential commission, so it was ordered by the president at the time, and it was investigating why the disaster occurred. This all, of course, happened on live television, so something that people really needed to know. Feynman, along with other famous astronauts and engineers like Neil Armstrong and Sally Ride, investigated the crash and were able to determine the issues with the space shuttle, and they recommended new safety measures and procedures for future launches, which NASA now uses. Feynman really managed to popularize physics through his lectures that were often recorded or broadcast over the radio to audiences and occasionally on TV. His lectures have been compiled and released as books, which you can buy in most bookstores. For those interested in viewing the lectures, they can also be found for free on California Tech's website at the www.feynmanlectures.caltech.edu. So all these lectures that have been recorded, you can go and actually watch for free on this website. No sign-ups or anything. They're just free to watch. Feynman also wrote several books about physics that were meant to be accessible to the public. His 2 works, Surely You're Joking, Mr. Feynman, and What Do You Care What People Think, are autobiographical and popular around the world. Ultimately, Richard Feynman has had a massive impact on American physics and also just generally our understanding of quantum mechanics, special relativity, and how they fit together. Feynman has inspired a whole generation of future physicists with his lectures and books, while also contributing greatly to our scientific understanding. His contributions are still in use today, showing the staying power of his work. Thank you so much for watching this video about Richard Feynman and all the great things he has done for physics. If you liked the video, please go ahead and like and then subscribe to the channel so you can see more of what we have to offer. Thanks again for watching, and we'll see you soon with more awesome videos. Bye.